Hello everyone. This is a worksheet on joint probabilities, conditional probabilities, as well as probabilities involving independence, rules of independence really. So what we see here is a contingency table, and a contingency table is nothing but a frequency table when we work with two variables. So the details of this example are not given in this worksheet, but let's try to understand what we are dealing with here. Across the rows, we have under 200, 200 to 300, over 300. These represent the weights, all right? It refers to the weight in pounds. And along the columns, we have the experience. So rookie, 1 to 5 years, 6 to 10 years, and so on. Now, this rookie suggests that it must be something to do with players. And below over here, it says a player on the New England Patriots team is selected at random, and we have to find the probabilities in the case of different scenarios that will be given to us, right? So that's what this problem, this example is about. Now we see over here the values, the frequency values given to us. These are not probability values. As you can see, most of these values are greater than 1. So we will have to calculate probabilities when working through the problems. However, we also need what's called the total columns, all right? The total column and the total row at the bottom needs to be filled out in order to calculate the probabilities. Remember, the probability formula is F over N, correct? So probability formula is F over N. So we have to know what N is. What is N? N is the sum total of all the frequencies. And then the F values will be the values at the center of this table. Okay, so I'm going to write down the total values. So 3 plus 4 plus 1. So the total of those under 200 pounds is going to be 8. Then we have 43, which is the sum of all those in this weight range, 200 to 300. And then we have 14, right? And when we sum it up, we have 65. And then for the different years over here, rookie, 8 plus 3, 11, 12 plus 4 plus 8 is 24, then 24 again, and then finally we have a 6. So the column total and the row total must all add up to the same value, 65, all right? Now, sorry about that. Okay, so let's go on to the questions. It says compute the following conditional probabilities. A player on the New England Patriots is selected at random. Find the probability that the player selected is a rookie. Now, is a rookie is a pretty straightforward probability calculation. All right, it's not a joint probability, as you can tell, because it's just asking about one variable, which is the years of experience. So let's try to find that probability. So the probability, the probability of finding a rookie, all right, probability, that's Y1, I think, all right, that's Y1. So probability of a rookie is, what should we do here? Take the sum total of all the rookies, all right? It doesn't ask for a joint value. It doesn't say rookie who's under 200 or a rookie who's in this weight range. It just says any rookie. So what is the probability of selecting a rookie? So you have to take the total number of rookies. It's going to be F over N. So F is 11, this value here, and N is 65. So 11 divided by 65, which is going to be 0.169. Part B is weighs under 200 pounds. So 200 pounds again is a pretty straightforward calculation. It's probability of W1. So under 200, you have to pick the total number for those under 200, which is 8. Right, again, same formula F over N, but this time it's 8 over 65, which is going to give us a value of 0.123. Part C says, is a rookie given that he is under 200 pounds, right? So a rookie, that means this is a case of conditional probability. There's a given condition given to us here. All right, so that means probability of Y1 given, so this separator here, this vertical bar, stands for given he's under 200 pounds, W1. All right, so what is the formula? You have to remember the formula or look it up from the formula sheet. So it's the probability of Y1 and W1 happening together, those two events happening jointly, divided by the given condition, so probability of W1. Okay, so probability of Y1 and W1, this is a joint probability, so that would be 3, right? Rookie, that's under 200, Y1 and W1. So there are 3 ways that we can have a rookie be under 200 pounds. So it's going to be equal to, let's work it here, 3 divided by 65. Okay, 65 divided by the probability of W1. So W1 was 8, so 8 divided by 65. All right, so which will give us 3 over 8. So it's going to be 3 divided by 65. This is fraction division. You have to change the division to a multiplication and take the reciprocal of the denominator. In other words, you have to flip the numerator and denominator of the fraction in the denominator. So 65 over 8. So we will have 3 over 8, which is approximately 0.375. Okay, and then the final one here says the probability of somebody who's weighing under 200 pounds given that he's a rookie. So it's the same events, but the conditional clause has been turned around. Earlier it was the probability of finding a rookie given it's 200 pounds. So the given condition was the weight. Here, the given condition is the years of experience. So this time it's going to be the probability of W1 given Y1. And the formula is probability of W1 and Y1 happening together divided by the probability. So the denominator changes. That's the difference from the previous case. In the previous case, we had P probability of W1. Here we will have the probability of Y1 in the denominator. So probability of W1 and Y1 is the same as probability of Y1 and W1. So it's going to be 3 over 65 divided by the probability of Y1 is 11 over 65. All right, 11 over 65 is the same thing that we had calculated here, probability of having a rookie, this here. So it will be 3 over 11, which gives us a value of 0.2727. All right, so here we answered a question which had to do with joint probabilities as well as conditional probability. So this is how you're going to work out problems on joint and conditional probabilities. We'll now work on this problem here on coin tossing. It says when a balanced dime is tossed 3 times, 8 equally likely outcomes are possible. And they've given us all the different outcomes from tossing a coin 3 times, right? So we can either have a heads in all 3 tosses, or a head in the first toss, a tail in the second toss, and a head in the third toss. Then we can have a tail followed by 2 heads. So these are all the combinations we can get from tossing a coin 3 times. And they have described 3 types of events. A is the event the first toss is heads. B is the event the third toss is tails. And then C is the event the total number of heads is 1. So let's take out the pen here first. All right, the event the first toss is heads, meaning the first toss will produce a head. Doesn't matter what the other outcomes were. B is event the third toss is tails, so the last one will be a tail in that case. And C is event the total number of heads is 1. That means there has to be 1 head and only 1 head in the outcomes, in the combination. So the first question says compute the probability of A, B, and C. So these are all individual probabilities, nothing to do with conditional or joint probabilities. So probability of A, all right, so probability of A is the probability of getting a heads in the first toss. So heads first. Let's describe it like that. So again, it's the same F over N equation, this formula. So we have to first figure out what N is. So the combination, all the combinations together are 8 of them, correct? So N is going to be 8. N equals 8. And that's going to be in the denominator. But F is going to change based on the event that we are looking for. So probability of heads first is going to be F over N. If N is 8, then F is going to be, let's see, how many cases do we have where heads landed first? So it's this one here, right? That's 1, 2, not here, but here. H is first, and then H first. So we have 4 cases. We can get a heads first in 4 different ways. So our F is going to be a 4. So it's 4 over 8, which is 1/2, which is 0.5 in decimals. The next one is probability of B. And what is B? Let's look at the event. It's the event the third toss is tails. So probability tails last. The last toss is a tail. Again, it's F over N rule. N is 8. So how many different ways do we see tail appearing as the third toss? So we have a tail here, we have a tail here at the end, here at the end here. So there are 4 ways by which we can get a tail as a third toss. In the top row, there's no tail in the third toss, correct? So 4 over 8 again, which is half, which is 0.5, half, which is 0.5. And the last one is probability of C. And probability of C means probability of 1 head. All right, 1 head in a combination. Again, F over N. N is 8. In how many cases do we have where head lands only once? Not this one, not this one, not this one here, right? This is one. We have one head. This is another one. We have one head. This is another one. All right, so 3 upon 8, right? So it would be 3 over 8. Which when converted to decimal is 0.375. Good. Now, part B says compute the probability of B given A. So this is a conditional probability. So what they're asking is for the probability. What was B? B is the third toss being a tail. So third tails, given that the first toss is a heads, right? Given that the first one is a heads. So let's see. What is the formula for that? Have the formula in front of you, all right? So probability of B and A occurring together divided by the probability of the given condition. So probability of A, which means probability of third toss and first H, all right, happening together, third and first, divided by the probability of first H. Okay, so probability of third toss and heads as the first toss, let's see, the numerator is still going to be 8. Denominator is still going to be 8, right? We are calculating the probability in the numerator here. So the denominator is still going to be 8, whether it's in the numerator or denominator. And third toss a heads and first toss a heads. So we have, let's use a different color. Third toss, this is 1 and this is 1, and those two are the only ones, correct? So it's 2 over 8 for in the numerator, and first being a head, probability of A we had already calculated, so I'm just going to take it from there, 4 upon 8. So we are going to have 2 divided by 4, which is 1/2, which is 0.5, right? So that's part B. The probability of B given A is 0.5. Part C is a question on the rules of independence. Are A and B independent events and why? What is the formula for that? How would we know whether events are independent or not? In order for that to happen, it's probability of A given B should be equal to the probability of A. All right, so we have probability of A already calculated up here as 0.5. All right, so let's write that on the side. Probability of A equals 0.5. We just have to find probability of A given B. Now, keep in mind that probability of A given B is not the same as probability of B given A. So you have to do this calculation before. We haven't done this in any previous question. All right, so we have to do this calculation. So probability of A given B, the formula for that will be probability of A and B divided by the probability of B. Okay, so probability of A and B would be the first toss being a heads and the third toss being a tails. It's going to be 2 over 8 divided by the probability of B is 0.5, right? It's 4 over 8. So it's going to be 2 over 4, which is 0.5. So now we can compare probability of A given B with probability of A, and we see that they are equal, right? So probability of A given B, which is 0.5, is equal to the probability of A, which is 0.5. Therefore, yes, events are independent. The events are independent. All right, so you have to show your work. You cannot just say events are independent without showing the work. All right, you have to show that, you have to prove that probability of A given B is equal to probability of A. Now part D says compute probability of C given A. So C is the condition that, or is the event that only one head appears in a toss, correct? So it's going to be, again, let's write the formula up front. Probability of C and A occurring together divided by the given probability, which is probability of A. So probability C and A would be how many ways we can have one head appearing only in the first toss. A is heads appearing in the first toss. So probability of one toss, so we have to narrow it down here. I'm going to erase this so there's no confusion. So probability of heads appearing once, so we have heads appearing once here, and then heads appearing once here, and heads appearing once here. Where any more? No. All right, so there are 3, but then the total number of heads is 1, out of which the first toss must be a head. So it's, excuse me just a second.